So today we'll be solving x squared plus bx plus c equals 0 by factoring. This is from your homework from the book, pages 255 to 258, 3 through 37 odd, and number 65. So let's take a look. First problem I'll do is number 3. Here we have a trinomial. So we have x squared plus 6x equals, or plus 5. So we have our a, b, and c. What we have here is we have an ax squared plus bx plus c. And before we learn how to solve it, we have to learn how to factor it. So number 3 just asks us to factor the expression. So we have a trinomial here, and we have a is just 1, and our b and c are different numbers. So we're going to see if we can factor that into two binomials. So what we learned in class is we have two binomials, and we have to figure out think about unfoiling. That's kind of what factoring is, or undistributing. We got to figure out two things in the front that will give us, when multiplied together, x squared. Well, x squared is really just x times x. In the back, we kind of have to think of things that would multiply to c, but add to b. So I got to think about all the factors of c and see if I can find ones that multiply to c and then add to b. So I'm just going to start to list the factors of c. Well, c is a prime number. It's 5, so there are only two factors of c, 1 and 5. They multiply to give me 5, and if I add them together, they would give me 6. So I can use those factors, 1, they're both positive, 1 and 5, and put them in the back, and now I have factored my trinomial. So again, what I need to find is need to find if x squared has only a 1, there's an x in the front and an x in the front of each binomial. Then I need to find two numbers that multiply to give me c and add to give me b, and those will be my factors in the back. And then this would be your final answer, x plus 1 times x plus 5. Okay, let's try another one. This one is a special cases quadratic. Here we have x squared minus 36, and we call this a difference of squares because x squared is something squared and 36 is something squared. We could rewrite this as x squared minus 6 squared because 6 squared is 36. And there's a special rule that we learned in class for difference of squares. When you have something squared, like a squared minus b squared, that can easily be factored into a plus b times a minus b. So we have a plus 1 and a minus 1. The important thing to remember is that it's whatever it is squared. So in this case, we have my a is really x. So I should have x, and my b is 6. So I'm going to have x plus 6 times x minus 6. Be very careful that in the back you don't put 36. You need to put whatever the square root of that is. So this is a special case, and we can easily factor that into a x plus 6, x minus 6. Okay, so the last problem I'll do is number 25. Here we're given a quadratic expression that's equal to 0, and that means we have to solve for x. We want to find out what our possible x's are, or our roots of our equation. In order to do that, we have to make sure that it's equal to 0. So if it's not equal to 0, we'll have to do some solving. Lucky for us, in this problem, it is already equal to 0. So all we need to do then is factor and then solve for our x's. So I'm going to go ahead and do that. This is an x squared plus bx plus c, where our a is 1, so I know that I'm going to get two binomials. And it's still going to be equal to 0. And in the front of my binomials, I need each of these terms to multiply to x squared. Well, that would be an x and an x. So x times x, that's x squared. However, in the back, I need to figure out two numbers that will multiply to give me a positive 30, but add to give me a negative 11. There's a couple of things I know that when I have to multiply to a positive and add to a negative, I know that both of my factors have to be negative. It's the only way I can multiply to get to a positive number, but add to get to a negative number. So let's start to list the factors of 30, but let's use both negatives. So I'm going to skip 1 and 30. I know those won't add to 11, but let's try negative 2 and negative 15. Those would multiply to give me a positive 30, but they add to give me a negative 17, so that does not work. So my next pair of factors might be negative 3 and negative 10. Negative 3 and negative 10, well, they multiply to positive 30, but they add to a negative 13, and that's also not what I'm looking for. So therefore, I can have 4 is not a factor of 30, so I don't use that. And then I can go into 5. Well, 5 is a factor of 30, so I do negative 5 and negative 6. Negative 5 and negative 6, they multiply to 30, and they add to negative 11, so I found my factors. So I'm going to use these as my factors here. I'm going to have minus 5 for my negative 5, and then minus 6 for that negative 6. So when I would FOIL this, then I would get back to my original quadratic. Now that I've factored it, now I can solve for 0. So I'm going to solve each individually for 0, because if they multiply to give us 0, then one or the other expressions has to be 0. So let's start here. We have x minus 5 equals 0. And then our other possibility would be x minus 6 equals 0. So we can add 5 to both sides here. And we can find that x could be a positive 5. Add 6 to both sides here. And we find that x could be a positive 6. So now that I've solved that, I have my two factors. These are the zeros of my function, what they're called, and we were able to solve this equation using factoring. If you have any questions, see me and Mr. Daniels, and have a great day.